Welcome back to 61D, the course where we teach you modern, full-stack web development. My name is Aiden, and today we're going to be finishing the project that we started in the last lecture, Lecture 3, by adding interactivity and state to our dice roller application. If you haven't watched the third lecture, please make sure to watch that first. All of the code that we will be building on top of we created in that lecture, and also all of the concepts that we're going to be building on top of were explained in that lecture. To recap where we left off, we built the visual display of our dice roller, but none of our buttons actually do anything. All we're doing right now is we are taking in some static data and displaying it. Today, however, we're going to have this data all be manually added by the user. So I can add a new die, my die. I can set the number of sides, add it, delete another die, roll my die, and clear my results. The key word and key concept that we're going to be covering today is the idea of state within a React application. For now, in your mental model, you can think of it as just being a variable. State is going to store some data, and we're going to update it. And just like a variable, we will reason about our application and have certain things in our application respond to state. However, state is not the same as a variable, and we're going to demonstrate this really quickly right here. All I did is in our DieInput, I created a name variable, which is going to track the value of our input, and a little names array, which we are going to render down here. If I wanted to store the inputted name in this input and then be able to hit add die and add another name to show up, this is the approach I might think to take. I have my name is going to start out as an empty string. In my input, every time the input changes, we're going to set the name to be a new value, and we'll also log that in the browser console just so that we can make sure it's changing. And then when we click our add die button, we're going to reset our name value and add the name to our names array, and hopefully that will show up down here. So let's give this a shot. I'm going to start typing in my name input, my die, and as you can see, our value is updating. This variable is getting updated by this onChange handler. Every time the input changes, we are setting the name value to the input and logging it right here. So we can input that, and then what we would expect to happen is that we click add die, and the name is going to get added to our names array, and then hopefully we would be able to see it down here. But let's see what happens. Nothing happens. Nothing in our UI changes, and even though we reset the variable name back to an empty string, our form doesn't even reset like we expect. But as you can see, it is actually getting console logged. There's actually 3 items because I did this demo once before, but right, our names value is actually changing. We could set it again, add die, and we keep on adding values to our names array, but this display never changes. The problem with the approach that we just showcased is that React doesn't immediately know when it needs to respond to changes in the value of a variable. In this case, all we do is we're just storing our names array, and we haven't explicitly told React that we want you to respond to changes in the names array and change what is rendered in the user interface when something in the names array changes. But fortunately, React does let us do this. We just have to use React State. I'm going to run through a super quick example and then we'll dive into it a little bit deeper. To start using state, you can type import useState from React. Then instead of declaring this names array as a static variable, we're going to set it as a state variable. So we can comment that out and say const names set names equals useState. And we'll give it an initial value as an empty array. Then what we're going to do is just when this button is pressed, we're going to say set names to be an array with name inside of it. There's a lot of things we need to clean up with this super quick, but it should showcase how we can change what is displayed in the UI in response to some action. So let's type in a name, my name, hit add die, and we'll see that our names array is set to my name. If we change it to say name2 and hit add die, our state will be modified and React will automatically update the UI based on that state modification. Let's break that down a little bit more slowly. First off, we import the useState hook from React because it is a core primitive within React. We'll get into the definition of a hook and why it's called a hook a little bit later, but for now, it's just something that we are importing and it's specifically used within React as opposed to some other type of JavaScript project. When we declare our useState hook, it returns a tuple, which is basically just a fixed length array that has two values. It has the actual state value, and then it has a setter function that allows us to modify the state. The reason that we need to use this setter function goes back to why we can't just use a variable in the first place. We need to use the provided setter function so that React can, everywhere else that uses this state, trigger a re-rendering of the UI. Going down farther, we can call this setter function to edit the value of name. We would never say name equals something like this. Anytime you want to, you never say names, for example, equals something directly, and this would also give us a lint error. The reason being that we need to explicitly use our setter function. Moreover, we in the future also always want to explicitly type our state values. See here, it doesn't really know what type of array it's going to be. So we can go back to the way we declared generic types and say that this is going to be a string array, like so, such that if we accidentally set names to a string, hello, we would get our type error that is making sure we are setting it to an array, like so, or set it to name. So what do we have so far? We don't modify state directly. We only modify state with the setter function. You always want to type your state value for all the same reasons that we have been using TypeScript. And when you use the state value somewhere, anytime it is modified, you have to, you will tell React that you want to re-render the UI and respond to that state update. Additionally, although it's not enforced by React in the sense that it's not going to throw an error. It is conventional to always have your setter function that you get from the useState function to start off with set, and then the name of whatever you named your state variable. Also, as you can see, we are able to pass in an initial value for our state. Right now, we had it as an empty array, such that it starts out as an empty array, but we could have it have some starter value like so. And then if we were to refresh, it starts out with that starter value. So dealing with arrays is a little bit complicated. So let's backtrack and first just handle the state of this input correctly. We're still using this static variable to track changes. So let's refactor that to be a state variable. What we can do is instead of using name like that, we can say const name input set name input equals useState string, and have it have an initial value of just an empty string. Then when the name input changes, we can say that we're going to set name input to that e.target.value. Don't worry about too much of what's going on here with this react.change event. Just e.target.value is the actual value of the input. Then let's try this out. If we're gonna type and type, that's all good. But then let's say we wanted to have this get deleted when we hit add die and clear the input for the next die to be added. To do that, we have to have the actual value of this input be controlled by the state. So what does that look like? All we need to do is say value equals name input. And now this input is completely controlled by our state value. So for instance, in the past we had this placeholder of D20 so that somebody could, easily see that that is the type of thing you might want to pass in. But now it's not even really necessary, because instead we could have a starter value. So say die1. And now our input is going to start off with that value. Then at the end, after we set name, we can set name input back to an empty string, like that. And then after we input our name and hit add die, it'll be cleared. This pattern is called a controlled input, and it just means that the value and the onChange handler of your input are going to be stored and set by a state variable. For now, this will work. Later on in the course, we will show you better ways to control inputs, but it showcases how you can use state to keep track of a value and then later do something with that value. Now I have a little bit of a challenge for you. Knowing that you can't just go names.push to add something to our names array, how could we go about adding an additional value to the names array instead of just setting the names to be the name input? Give that a try really quick, and then I will show you how to do it. So something that might immediately come to mind is to just create a new array from the name input. So we can do that. We can say const new names equals the existing names equals names. And then you could say new names dot push the name input, and then set names to be new names, like so. And this will work pretty well. So we could create a die, die1, add die. Maybe I'll have it start off as an empty array. I'll make it a little nicer. So die1, add die, die2, add die, like so. And we're able to add something to our array. If we wanted to use some nice shorthand that we've learned, what we could do is instead just have this be a single array where we spread out the existing names and then add the name input name all in a single line. And at first glance, this works pretty well, just like we would expect. However, something that's a little bit unintuitive about state is that state updates don't happen immediately. You can't necessarily think of a set state operation the exact same way you think of a normal JavaScript operation. For instance, inside this onClick handler, if we were to execute some code up here, so if we were to do some code, we would expect that if we were to access the value down here, the result of some code would have completely executed by the time we get to this execution later down, and we could use any calculated values up here. The problem is that state updates have to do with rendering. What that means is that React does lots of stuff under the hood to make the updates to rendering faster. Sometimes these updates will be batched, and there's many kind of unexpected behaviors which happen, which basically means you shouldn't think of state updates as being instantaneous, the same way you could with some other JavaScript code. For this reason, anytime that you have a state update, which depends on the previous state value, which in this case, our setNames function depends on the previous names value, you need to do something a little bit differently. And we can demonstrate this by trying to just run this setNames twice. So what we would normally expect if this was a typical JavaScript function is that we run the first setNames operation, it takes in the names, adds the new name input, and then completely executes before the second setNames operation, such that this would add our new name twice. But let's try it out, see what happens. So we have an empty array. If we hit add die, we would expect the array would have two values in it, both with name die1. But instead, it only adds a single value. This is because we didn't explicitly say, hey, when you're running this second setNames, make sure that all of the first updates from the first setNames are finished before you get this names value. To fix this, instead of taking names from up here, the setNames function will actually give you the current state value as essentially an argument. So let's rewrite this and then break it down. We can instead say previous names and have it be a function which evaluates to the previous names and then the name input. So what this is doing is we're passing in a function to our set names, which is going to use our previous name's state as a part of our state update. It might be a little unintuitive right now, but if we run this twice, then we actually will get our expected result. So we can say die2, and if we hit add die, it will add the die both times because it will finish this first set names update and then do the second set names update with the actual completely updated state. So in summary, anytime that you are updating the state to use, and your state update function needs to use the current value of the state. For instance, here, we don't care what the current value of the state is, we're just completely resetting it. But here, we do care what the current value of the state is because we want to keep all of the current state and add something else. This is the pattern you need to follow. Mostly you're going to encounter this when you're dealing with arrays and objects in state, but you'll see throughout the rest of the video, you want to follow this pattern instead of accessing it directly when you're updating state. So now we're ready to completely finish out and control this DieInput with state. First off is let's add a second state handler for the number input. So we can say number input, set number input, number input equals useState, and this is going to be a number, and we can set it to initially be 6. Then with our input here, we can say that the value equals number input, and on change, we take that event and we say set number input to be e.target.value. This is actually going to be a type error because it's going to treat this like a string and we need to parse it into a number. So to do that, we can just say number like so, and this will try to convert this string value into a number just like we want. Then we really should have some more complicated state here. Instead of just using a string array, we need to use our dice type. So we can import type die from our dice types. As a reminder, we did this in the last video, set up the type that we expect to store our dice. And then instead of doing names, we can say dice, and then set dice, and set this to be a die array. Then we can just render the dice and do our onClick handler. So we can set name input to be an empty string after this, and we could also set number input back to our default value of 6. And then I want to challenge you, think about how we would write this set dice really quick. And then I will show you what we can do is set dice, use our previous dice array, so we'll call it previous dice, and return our previous dice, and then a new object. If I forgot what properties, again, I can always do my control space and see what I have to define. The name is going to be the value of the name input, and the sides are going to be the value of the sides input. Number input is what I named it, number input. like so. So let's give this a shot and see if we're able to successfully add dice to our array. We can start off, we've got die 1, side 6, add die, there we go. We have name die 1, side 6, can add a die 2, which could maybe be just like flipping a coin, two-sided die, and add die. And we're going to dynamically re-render using our state value. So there you go. That is the intro to state. And now we just have to use state to make the rest of the application reactive and interactive. Now let's move down from our die input to our actual die display and take a look at what we might need to do there. So we can open up the die display, and as we can see, we need some way to take in the dice so that we can render them. And then on here, we need to be able to make our X button actually be able to change our dice state. This is a little bit of an issue though. If we look at our app.tsx file, we can see that our main high-level app is rendering the die input, die display, and roll results all as children of the app. The issue is there's no way, as we have it currently written, that we can have the local state of the die input eventually get passed into the die display. Let's take a look at this with a little bit of a diagram. Our app.tsx is the top of our application, and it renders all of our 3 children below it. Currently, dice state is only located within die input, but we want to be able to move this dice state. Oh, I need to do squiggle. We want to be able to move it over there, like so. The issue is that there's no way of doing this. We can't pass state sideways between components. The only thing that we can do is we can pass it, is that we can pass it down from a parent to a child. So what we need to do is we need to take this dice state and move it up into our app.tsx such that then afterwards we can pass the dice state down into each component that needs it. Then both our die input and our die display will be able to access and mutate the same dice state. And when our die input changes something about the die state, our die display will automatically react to it because they're all subscribing to and using the same state. So that might be a little confusing when you're just looking at it as a diagram, but let's try to actually implement this. Currently, our die input doesn't take any props, but we can have it instead take in the actual dice and the set dice state. So for now, let's just move a copy of this up to our app.tsx, import useState. Up here, can declare this, and then we're gonna have to import the die type, import type. And then what we want to do is we want to pass our dice and our set dice down into the input so that we can then pass it into both the display and the row results. Okay, so let's define our props. We need to specify the type of this dice value and also the type of the set dice value, because those are the two things that we're going to pass in. Little trick, if you don't know, hey, what is the type? What is the type? Just hover over it and copy and paste that type. So for the DieInput props, we can just say that we're going to have dice and we're going to have set dice. And if we want to get the type, hover over it, copy, paste. It's pretty self-explanatory. The type of set state actions are a little bit more complicated because you need to be able to support a direct set state like this, or support the callback function set state like this. But if you just declare it, then you can just copy and paste it like that. Then we can take our dice and set dice as our die input props, and then move this up into the app.tsx. And as you can see, right, there's no errors because it's going to expect dice and set dice to work the exact same as we had before. Just instead of being defined locally, we're going to bring that state up to app.tsx and then pass it back down into each of the child components. So we can have it like so. Make sure you import useState from React and also import our die type. Then it's going to say, hey, we need these properties. So we can say dice equals dice and set dice equals set dice. Now let's save this file and give that a shot in our app. You might need to refresh the page and also just make sure your files are saved. But now we can have our die1 with side 6, add die, and it gets displayed like so. We can do this again, say die2, sides 8, and our function works the exact same. But now we are able to also pass it in directly to our die display. We can get rid of our sample dice and instead pass the actual dice state. And we can get rid of the JSON stringify down here and maybe refresh the page so that we clear the die results. Die1, side 6, add die, and boom, it is getting used by our die input, it is getting used by the die display. It is able to behave the exact same. The dice are the exact same format that it expects, but instead of having our static data, we are now able to have this working die input. We can add as many die as we want. Add die, add die, and it'll keep on going. And we now have a beautiful reactive application. The only thing we need to do now is we need to figure out how we can actually have these delete functions work to get rid of the dice. So let's try this out. How would we create a function to delete a given die? What we're going to have to do is we're going to have some kind of set state operation. And the thing we're going to do is we can just use for now the actual index, and we need to be able to delete the die with a given index. If you want, you can try this out yourself. Think about how you would write the set state to delete a die. You can write it as const handle delete, and then deal with that. And then we would need to pass it into the die display so that when this button gets pressed, we can actually remove it from state. So think about that for a second. and I will slowly go through it, and if it sort of gives you inspiration of how you would finish it out at any point, I encourage you to take it over and try it out for yourself. First thing is, if we're going to take another function in the die display, we have to add it to our props. So we need to take a handle delete is going to be a function, and it's not going to return anything, so it's just going to be of type void. But we need to be able to differentiate which die in particular we want to delete. For that, we can just use the index within the array. So we can say that it's going to take an index, which is going to be a number. Then we can actually destructure it here, handle delete, get the index, and then when this is clicked, on click, we are going to handle delete for the given index, like so. That's the only change that we need to write in the die display. But then in our app.tsx, we have to actually create the handle delete function. So this is going to take an index number, and then we can say handle delete equals handle delete. And now we need to write the setState operation to remove an index from the array. So think about that for 1 second, how you could do it. One little hint, use that filter function from earlier. You can use the filter function, and inside of the setDice state handler, you can use the previous value of the state. So think about it. If you get stuck, we can say set dice, take in our previous dice and the index. Wait, is that getting a little ahead of myself? Just take the previous dice and return previous dice dot filter. And the condition, we don't need to take in the value, but we get the value and the index. And we return true to include this dice if, we should actually have this be something named different. Say die index, return true if index is not equal to die index, like so. So breaking this down, it's going to filter out the previous state values and get rid of the one in which the index equals the die index. So now let's try this out. Can delete, add something new, hello, add die, and then delete it, just like so. Works beautifully. One other little convention is if you ever need to destructure some property and it's not used. So in this case, as we're filtering the dice, we only care about the index. We don't care about the actual value on the dice. Just put a little underscore in front of it. And that says, hey, we're deliberately not using this as opposed to accidentally not using this. So there you go. We wrote a state handler to, again, handle some complex state and deal with this array and filtering out to remove the die with the given index. Now we've covered everything that you need to finish out the implementation of our dice roller as it currently exists. There's only 3 things left to do. First is we need to declare some state to store our die results so that we're not importing the static data. We need to handle what happens when we click the roll button, and we need to handle what happens when we click the clear button. I'm going to walk through implementing all 3 of these things really quickly, but I would highly recommend trying at least a few of them yourself to check your understanding, because to do all three of these things, we don't have to cover any new concepts. So first off, setting up some results state. Similarly to how we have our dice state, we can say results and set results. Set results are going to take in, or are going to be of the die result array, die result array. And then we can pass that in instead of doing sample rolls. Actually, this is going to be a two-dimensional array. I lied. So for example, we could say results instead of sample rolls, results and results dot length. So that works. And then for the roll result, there's nothing at all we need to change because handling the roll and the clear is all going to happen up here. So there, that is step one. For handling our roll, what we're going to do is for every die in our dice, we're going to calculate a random roll and then add it to our results array. So it's going to be a little bit complicated, but we can break it down. We can say const handle roll. It's not going to take anything in except for the dice state, and we can just use that dice state directly. So what we need to do is we need to create a new die result array, which we're going to append to the results two-dimensional array. So we can say const round results is an empty array of type die result array. Then we're going to loop through each dice in the set dice. So we can say for const die of dice, like so, and each one of these is going to be an individual die. We need to get the random roll result. To do that, say const result equals math.random. This is going to get us a random number between 0 and 1. Then in order to make it between 1 and our actual sort of max value of the die, so for example, if we wanted to make this between 1 and 6, we could say math.random times 6. This would make it, instead of between 0 and 1, 0 and 6. And then we can say math.ceiling, math.ceil, which is just going to take the ceiling. So we have our result, which is going to be the ceiling of our number between 0 and really 5.9999. So this is going to give us an integer between 1 and 6, although instead of 6, we want it to be die.sides. Then what we need to do is just add it to our array. So we can say round results dot push a new object, which is going to be the value of our die, and then also a result of just result. If your property is named the same, you can just pass it like this as shorthand for result, like so. And we know that because we don't get any type errors. Finally, we can just set results to, again, our pattern for adding something to the end of the array. We're going to take the previous and return the previous and then the new run results, like so. Now we can try binding this to the roll button. On click is going to handle roll and see if this works. So just make sure we're all cleared. Add a new die, add die, add die, and then roll. And there we go. We get, I guess, a little bit of an issue because our second die doesn't have a name, but one of the die got 3 out of 6, the other got 1 out of 6 for a total of 4 out of 12. We can delete that die that doesn't have a name and say it's die 2. Add die, roll, and then our next roll. It looks like they're going in the wrong order. So we can, it looks like we're flipping them here. So we can instead switch these. And then, clear doesn't work yet. So add die, die 2, add die, roll, roll. There we go. Now they're going in the correct order. Each newest roll is on top, and we have our whole roll history going down there. So that is handle roll. Now finally, handle clear is going to be pretty simple. You can just say handle clear. All it's going to do is set results to be an empty array again. So then we can bind it here. On click is going to handle clear. And there we go. That is 2 and 3 done. And now we have a completely functional, except for the data persistence after refreshes, but we'll do that in a bit, completely functional die roller. We can add our die, die 2. They can be any number of sides. Well, any number of sides with a minimum of 2. Add die, can do a bunch of rolls, and then when we're done, we can clear them, just like so. So there you have it. That is the interactivity. We can now completely delete this sample data because we're not using it. And now you have a dice roller. Congratulations. That you can count as, a slightly more complicated project than just a hello world. But as you can kind of already tell, there's a couple finishing touches we might want to put on this. And there's also a better way that we can manage all of this different state handling, which we'll talk about in a second. There's one other extremely common pattern that we haven't talked about yet and isn't super necessary for our application, but it still might be nice. And that is the concept of conditional rendering. So far, everything in our UI is always going to render. However, you could imagine we might not want this to be the case. For instance, it doesn't necessarily make sense to display the roll results or the clear button if the results don't, or if there are no actual roll results. So we could imagine that once we hit clear, we might want to get rid of the clear button so that it's not a distraction and it's not something that you can actually click until there are some rolls. To do this, we're going to go back to the JavaScript concepts that we covered at the very beginning. If we look at the button here, what we can do is render it within some curly braces and use the concept of short circuiting that we talked about way back in lecture 1. So what we want to do, the behavior we want to achieve, is we want to say that we are only going to render it if results.length is greater than 0. So what we can do is say results.length is greater than 0, and, so double ampersand, our button, like here. What this is going to do is it's going to evaluate this condition. If it's true, it's going to evaluate and return the button, but if it's false, it's just going to return false. And if you have false within JSX, then it's not going to render anything. So if this condition is false, we're going to get this. If this condition is true, we're going to get this. So let's test it out. If we clear, we can see it disappears until we add a roll, and then our clear button is back. Another common thing is we might want to use our ternary operation that we had before if we want to render something different depending on whether or not this is true or false. So we could refactor this to instead use our question mark and say, hey, if this is true, we're going to render the clear button. Otherwise, we'll render just a paragraph that says, roll some dice to see the results, like so. And now we have conditional rendering. Depending on if there are any rolls, we will either see this message or our clear button. If there's something that's a little more complicated, for instance, let's say you wanted to have an if statement with 4 or 5 different possibilities, it might make more sense to render that as a separate component or really just up above with some JavaScript instead of doing it all inline in JSX syntax. For instance, let's say we wanted to have some kind of max number of rolls. And if we get longer than 10, we want to include a message that says you should really clear some old rolls. How would we do this? The best approach is to extract the rendering logic into its own function, and then we can call it. So let's say const roll CTA, as in roll call to action. And we're going to have this function depend on the state of the results. So we could say if results.length equals 0, we will return something. Else if results.length is less than 10, we can, or let's do a smaller number, 5, and return something. Else we'll return something else. So if results.length is 0, we could return our paragraph tag. Like so. Otherwise, we might want to, maybe we only want to allow the results to be cleared when there's at least 5. So we could say return the button down here, and otherwise return another paragraph where we could say there are results.length results. All right, what is this error? Else clause can be omitted. Don't worry about this. This is just the linter complaining that theoretically we don't actually need this else clause. This doesn't have to be, why is this saying else clause? Don't worry about it. Then down here, to render the result of this roll CTA function, we could just do roll CTA and call it. And now we have some conditional rendering logic that is a little easier to manage because we can write our nice JavaScript around it and we don't have to do everything in line. So let's see, it says there are 2 results, but if we keep on rolling, it'll give us the option to clear. And then it says, roll some dice to see the results. So far, our application is pretty simple because there's only one layer of hierarchy of our components. We just have our parent, app.tsx, which passes down the DieState, only a single level. However, imagine we had a component within a component, within a component, within a component all the way down. And we wanted something way, way down here to be able to access that same state that we have all the way at the top. With what we've learned so far, our only really approach would be to keep on passing it down as a prop. So from this DieInput, we'd have to pass it down. And then from this other component, we'd have to pass it down again, and again, and again, and you get the idea. With our example, it's not super immediate what type of situation you would have where your input would have a component on a component on a component on a component. But once you start building complicated websites that have many nested layers of layouts and components within components, this becomes extremely common. And fortunately, React provides us a better way to handle this called context. Imagine that instead of having to explicitly define what state we're going to pass down and pass down and pass down and pass down and pass down, what if instead our bottom component could go all the way back up top and grab just the state it needs? React allows us to do this with an idea called context. A better way to think about our component structure isn't as if we have some hierarchical thing that is passing information down into each child. A better way to think about it is that your top level component wraps all of the children and puts them into one sort of consistent namespace, one consistent context through which it exists separate from the rest of the application that might exist, somewhere over here. And when you look at our code, you can see that our app is literally wrapping our DieInput, our DieDisplay, and our roll result. Earlier, we already showed an instance where we had to take the state that was getting stored locally in the DieInput, and we had to raise it up higher up in our tree, in our sort of tree of components, so that it could then get used in other components that were at its same level of hierarchy. Context is the idea of wrapping either the entirety or a large percentage of your application such that your data gets put all the way at the top of your app, and then any component that is wrapped by it can access it. So imagine we had a big circle which wrapped the entire app and stored some data and functions in context. Then because it wraps all of these child components, each child can go grab exactly the pieces that they want. So for instance, our DieInput doesn't actually need the data, it just needs a function to add to that data. So we could just define some function, I need my little pencil, just define some function that goes into the DieInput. The roll result doesn't have to have any functional requirements, but it needs to be able to subscribe to certain pieces of data. So roll result could specify, hey, I just want some data from the context. But then later, if I want to add some more functionality to roll result such that it needs a greater slice of this context that we define, it can simply declare it and grab it the same way it's grabbing the existing data without us having to specify a prop that gets passed to app and then gets passed to roll result. To get started with context, first create a new folder and call it hooks. The reason being that when we create the context, we also need to create a specific hook which allows us to subscribe to individual items within the context. That is sort of the same as how useState works. useState is called a React hook, and it provides us a piece of state, a piece of data, and a function to alter that data. And then anything that uses it, you can think of it as subscribing to that state. So we're going to create a hook, and it's going to have the context and the hook to subscribe to or hook into that context. So we'll create a new file and we can just call it useDice.tsx. The convention with all React hooks, useState and all the other ones that we will encounter, and the one that we're going to create right now, is you prefix it with use and then say what you're doing. To start, we need to define the type of what is the data we want to store in context. If we look back at our app.tsx, we have two pieces of state, which it probably makes sense for us to move up into context. So we can import those two types, import type die, and also type die result. And then we can create a type for this context. So we can say type die context. We'll have our dice, which will be a die array, and our results, which, if we look back at our app.tsx, is going to be that two-dimensional die result array, like so. So that is the type of our context. Then we need to actually create a context of this specific type. To do that, we can import the create context function from React. And while we're at it, there's a couple other things we're going to need. We're going to need to have the use context hook and the useState hook. But for now, all we need to do is say const dice context equals create context, and it's going to be of that die context type, like so. The only issue is that we normally don't initialize the context right here. So what we're going to do is say it can be either the die context or undefined, and we're going to set it initially to just be undefined. So now we've created this context. Now we need to create the wrapper component that's going to wrap our application and allow us to use the context. It's going to be what is called a provider for the context. So let's do this. Let's say export const die provider, or we'll say dice provider, which is going to wrap the rest of our application and provide it with the necessary context. For now, we can just say that it's going to return a dice context dot provider, and then the value for now of the context can just be undefined, like so. So this value is the value we're going to pass in to the context initially, and then we're going to wrap the rest of our application inside here. But how can we do this? How can we have this application wrap another, or how can we have this provider wrap another component? The way we can do it is with a special React prop called the children prop, which essentially is just going to render inside of the provider. to properly declare that, we can say that we're going to take it as a prop. And to make sure that it is going to be the correct type, we can say that children is going to be a React.React DOM, or sorry, no, it's actually going to be a React.React node, like so. So what this means is that this children is going to be some React component. In this case, it'll be our app component, which eventually we will put in here. And then the dice context provider will live on the outside and completely wrap that entire application. But we don't want the value of our context to be undefined. We want to actually hold some state in here. So what we can do is we can copy and paste this state from our app.tsx, declare it within our provider, since this is a React component, and then pass it down in the context. We can say dice are going to be our dice, and our results are going to be the results. Finally, last thing we need to do before we can start using this is we need to create a hook to actually access this context. So far, we've created the provider, which is going to hold the context. Now we need to create a hook to be able to access it. So as I mentioned, the convention with React hooks is to say use as the prefix. So we can say const use dice is going to be a function which is going to return something. We can actually create the context, or sorry, we can use the context within this useDice hook. So we can say const context equals use context, and that's going to take some context. So in this case, our die context. And then we are just going to return the context, like so. There's some more things we need to do, but this is the base bare minimum that we can do to actually hold our state and then store it. So let's give this dice an initial die. So we'll say an initial test with size 6 and see if we can use this context. First is we need to wrap our app with this context. So let's go to main.tsx, which wraps the app. We can import our dice context, or sorry, the dice provider, and then wrap the dice provider around the app. As you can see, if we don't pass anything, it's going to give us an error and say that it expects some child properties that it's going to wrap. And if we make it wrap the app, then we are all good. Then within the app, we can import use dice from the hook, and we can subscribe to some piece of this context. So we can say const, we'll just say const dice equals use dice. And as we can see, it is going to be of the type die context. Then if we go back to our use dice and properly type this context by saying it's going to be of type die context, go back to app.tsx, we can destructure the either dice or the results from our useDice hook. So let's just get the dice for now and call it context dice. And then if we were to go down and we could just json.stringify the context dice, then we can refresh and see that we are using this data from the context. It's defined in main.tsx. We have the provider, which initializes our dice value and makes it accessible to all components that it wraps. Then the app.tsx uses our custom useDice hook to hook into that context, take out a piece of it that it specifically says it wants to use. And if we wanted to change this and also include the results and say this is context results, we don't have to change anything with the props because our app is already wrapped with the context. A couple other things, we have a type error here because this hook is supposed to return the die context, but this context could technically be undefined. This is because we want to make sure that we throw an error if we accidentally try and hook into the context in a component that isn't wrapped by the context. Going back to our example, if we had some component out here that existed outside of our wrapped context and it tried to hook into some of this value, we would want to throw an error because it has to exist within the context to use the context. So all we can do is do a quick check, say if context equals undefined, then we can throw a new error and just say must use useDice within a dice provider. And then we don't get the type error because this is guaranteed to be defined. So there you go. That is an example of using context. Now we can go through and see how this can tangibly make our app a little bit easier to use. First off is we don't have to have all of this complex state logic inside of our app.tsx file. And if there's any of it that we might want to pass down, we can just store this in context and have it all defined in one place. So I will put these side by side. We can copy and paste handle delete into here. And it's going to use our same setDice function. Can copy and paste handle roll. And even handle clear. I'm going to go one step further and also take our DieInput function and create a specific function for handle adding the dice. So we can say const handle add. Hopefully it doesn't block me too much. And copy and paste this logic right here, like so. Then we can simplify this a little bit. Our handle add is going to have to take a new die, and we can just set dice to be previous dice and then that new die, like so. So now we have all of our state handling logic and all of our setter functions in one context. And further, we don't even have to expose the direct set results and the direct set dice to anything except this internal context file. This means that if somebody keeps on creating more and more components and you have certain expectations about what dice and results can be, you can specifically only expose the ways in which you want this state to be allowed to be mutated. You can say, hey, I'm only going to let you delete a single thing at a time, or I'm only going to let you handle roles in this specific way. It provides a nice interface which allows somebody who is using this context to understand what actions are allowed and not allowed. So then if we want to expose these other functions to our context, we can update this type. So handle delete is going to be a function that takes in an index as a number. and it's not going to return anything, so we're just going to say it's a void. Handle roll is not going to take anything in and just be a void. Handle clear is going to be the same. Handle clear. And then handle add is going to take die. So handle add is going to take a, well, it's going to be a void function, and then it's going to take a die. Now, as you can see, it's complaining that we're not passing everything in, so we can just pass in handle add, handle clear, handle delete, and handle roll, like so. And now all of these functions exist as part of our context. So let's do some refactoring and use only this context and get rid of our locally stored state. So here we can delete these useState calls. Make sure this is just named dice and results for consistency. We don't need any of this state handling logic locally. And we can instead use the individual functions that we want. So we can say handle clear, and then that will be defined. Get rid of that. And then handle roll is going to be there. Handle roll. Oops. And handle delete. Handle delete, like so. And now here is the key benefit of context. Since our DieInput is within the app and the app is within our context, we can completely get rid of this set dice prop. So we can go in, completely get rid of it, and instead just import our useDice context. And instead of handling the state logic here, we can just say const handle add equals useDice, and just call handle add and pass in for our die sides. We can have the sides input. What is it? Number input. Should really rename that. And for the name, it will be the name input, like so. So after we went through that work to define that, dice array, yeah, so we can actually completely get rid of all of these props. The input now no longer needs to take any props. Look at all this code we're able to delete. And we don't have to pass any of that in, like so. So that was a lot, but let's circle back and make sure that everything still works the way we expect. Let's try to add some dice. We can do that. Accidentally added some dice with empty string names. So say die2, add die, and then we can roll, handle rolls, and everything works exactly the same as we had before. However, using this context means that we didn't have to worry about passing props. Yeah, even in the die display, we don't need to pass handle delete. Can get rid of this, get rid of this. And then within the die display, we can get rid of handle delete, import useDice, and get our handle delete equals useDice, and get rid of that. And there we go. Yeah, beautiful. We don't even need the dice here because we can just get the dice from context and completely eliminate that prop. So circling back now, the only thing that needs any props is just our roll result display, and that's because we need to pass in what specific result we're displaying. However, you can imagine that if we had a component that rendered all the results instead of one that just rendered an individual round, then we wouldn't have to pass in the results array. We could instead just take it from context. The final last React concept that we're going to cover today, and the final thing that we need to do in order to fully have the dice roller we have created match the functionality of the template, is we need to figure out how we can persist our state and keep it stored in the browser somehow. So fortunately, the browser has a couple ways of storing data locally. The one that we're going to exploit is called local storage. You can go and inspect, and then inside of the browser console, go to Application, and then click on Local Storage. And you'll be able to see we have a little key value store that is able to give a certain key and then store a certain value. So what we have is every time either the dice or the roll results are updated, it's going to convert that state into a string and store it in there. So we can see, we can add a roll, and then it's going to get stored. And then it's also going to get loaded back into state when it gets refreshed. So React provides a specific hook for dealing with situations where you have to have your React application talk to some external system and you need to have it respond to changes in some external system. It's called an effect. So it's going to be the final hook we use for today. It's going to be called useEffect. You can think of it as, imagine you had some external piece of data that you're fetching from an API, and you want to change what renders in your display after you fetch that piece of data. You somehow need to be able to listen to that external thing, say, hey, is it there? Is it there? Is it there? And once it's there, you can update. We're not actually going to handle data fetching with useEffect. We're going to use something much, much better. But a common use case for useEffect is dealing with browser APIs like this local storage API. So what useEffect does is it declares a list of dependencies, and it will trigger every time one of those dependencies are changed. So it works well with useState. To declare it, let's say useEffect is going to call some kind of function, and then it's going to rely on some kind of dependency. So we can just say it's going to call a function, and then it's going to have an array of dependencies. So for instance, if we wanted to just console log my depend, we'll have this one have to do with state. So this one will have to do with, dice. So console.log dice changed. And then if we put dice in here, okay, don't worry about that error for now. We will fix it later. Then every time we update something about the dice, this effect will run and have dice change. So if instead of just console logging, we want to store our dice in local storage, we can say local storage.setItem. Then we need to provide a key. In this case, we can just say dice and a value, which also has to be a string. If we want to convert our array into a string, we can just say json.stringify dice, like so. Now this effect, which is used to sync our local React data with the external data handling of the browser, will run every single time a die updates. You can imagine that we could technically manually update it in our handle delete, in our handle clear, in our handle add, but doing that is going to require a lot of code, especially if we increase the number of event handlers we have, whereas this will simply listen for changes in dice and store them in the browser. So let's check and see if this is working. Can go to local storage. Don't worry about that guy and that guy, but we can see our dice. We can try adding a die, and there we go. It's updated. So let's try and refresh. And it's not working. The issue is we also need to load from local storage. So in our context, instead of setting it to have this default value, we can instead say json.parse, because we don't want to store a string. We want to marshal it into being this dice array. And then we can say local storage.getItem dice. And this could possibly be null. So if it is null, we can just use our nullish coalescence and instead just pass in an empty array as a string, and that will get parsed into being a dice array. So now let's try this out, and we can see refresh, 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 and it is reloading that data from local storage. Then if we delete, it gets reloaded. Now you can try yourself implementing the same thing for the results, but it's going to be pretty similar. Can copy and paste this effect for results, give it a different key. Instead, we want to store the results, and we need to update the dependency, and then we need to get our results, like so. Now, if we roll, they will be saved and loaded back, stored in local storage. This even works if we close and reopen the tab. They'll still be there from local storage. And there you have it. In the last two lectures, we talked about the basic structure of a React app, how you can define your own components and pass props into the components, and most importantly, compose components within components. We dealt with handling state before eventually moving it into context, which makes it a little bit easier to use sometimes. And we dealt with external effects and handled them with useEffects. There's a lot more to learn with React, but it makes sense to learn those things as you go, as you start working on more complicated projects. This is more than enough to get started. But as you notice, our dice roller is pretty ugly looking. So in the next two lectures, we're going to learn about styling and CSS, and more specifically, a variant of CSS called Tailwind CSS, so that we can make our dice roller or any other application look absolutely beautiful. Until next time, check all the links in the description for additional resources, timestamps, and other goodies, and take care and stay tuned.